Every time you stream a movie or ask an AI a question or, just save a file to the cloud, you're tapping into this massive hidden world. It's a physical universe of buildings and servers and cables that really form the beating heart of our digital lives. And these aren't just any buildings. They're called hyperscale data centers, and they are growing at a rate that is just truly mind-boggling. And the sheer scale of that growth, well, that's where our story begins.
To give you a sense of what we're talking about, let me just throw a number at you. $1 trillion. That is the projected investment in North American data center development alone, just between now and 2030. This isn't just growth. It's a flat-out gold rush, and it's all being driven by our absolutely insatiable demand for data. All right, so here's what we're going to cover. First, we'll break down what a hyperscaler actually is and meet the giants behind the cloud. Then, we'll get into the data explosion that's fueling all this growth, the hidden environmental costs, the big push for sustainability, and finally, that constant tension between growth and its impact. So, what do we actually mean when we say hyperscale? It's so easy to just think big, right? But it's so much more than that. It really represents a fundamental shift in architecture, a completely different philosophy for how you build and operate the cloud. Okay. So at its core, hyperscale computing is all about elasticity. It's this ability to add massive amounts of resources, computing power, storage, you name it, just seamlessly, almost instantly whenever demand spikes. Think of it less like building a bigger house and more like a living organism that can just grow on demand. Now, the industry has put some numbers on this, kind of like a baseline. To even get in the door and be called hyperscale, a facility needs at least 5,000 servers and 10,000 square feet. But honestly, that is just the starting line. The modern facilities we're talking about absolutely dwarf these minimums. We're talking hundreds of thousands of servers. And when you compare it to a traditional data center, the difference is just stark. Instead of being this single, rigid, hardware-focused thing, a hyperscaler is modular and totally defined by software. We're talking 100,000 servers or more, and power draws that can go over 100 megawatts. That's enough to run a small city. At this scale, we're not even talking about single buildings anymore. These are sprawling campuses, basically cities made of servers, often hidden in plain sight. So who is actually building and operating this world? So who are these titans building these digital empires? Well, it's a surprisingly small and exclusive club, with names you are definitely going to recognize. The key thing to get here is that this market is an oligopoly. The immense cost and the sheer complexity create this massive barrier to entry. And what that means is a huge portion of the world's digital activity flows through infrastructure that's controlled by just a handful of corporations. I mean, just look at the numbers. 3 companies, Amazon Web Services, Microsoft Azure, and Google Cloud, they control nearly 2/3 of the entire global cloud market. Their decisions don't just affect their own bottom line, they are effectively setting the rules for the entire tech world.
So what is driving this relentless expansion? I mean, what's the fuel for this fire? It all comes down to one thing, an absolute explosion in the amount of data we create, process, and store, every single second.
This timeline right here shows a stunning reversal of power. Back in 2010, private data centers ran the show, but by 2018, the cloud was hosting almost 90% of all computing. And the growth is only speeding up. We're projected to hit 180 zettabytes of data by 2025, and US power demand for these data centers is set to double by 2030. It's just staggering. But all of this digital magic, it comes at a steep and often hidden environmental price. These massive facilities are incredibly thirsty for 2 really critical resources: power and water. So get this, in 2022, data centers consumed an estimated 460 terawatt-hours of electricity. That is nearly 2% of all electricity used on the entire planet. And what's more, that number is projected to double by 2026. And it's not just electricity. To stop hundreds of thousands of servers from literally melting, these places use immense amounts of water for cooling. A single hyperscale data center can chug through between 1 and 5 million gallons of water every single day. This is not some abstract problem. This quote, it's from a news report about a community in rural Georgia, and it just highlights the real-world consequences. When a massive data center moves in next door, it can create direct competition for a resource that entire communities depend on to survive. Now, in response to all this growing pressure, the tech giants are in a flat-out race to innovate. They've made these bold, public promises to build a greener, more sustainable cloud. And the public goals? They are ambitious. Net zero emissions, 100% renewables, even becoming water positive.
But the day-to-day operational reality, well, it's a lot more complex. Behind those promises, a lot of facilities still rely on older control systems, and just tracking the true carbon footprint across a massive global supply chain is an enormous challenge.
But real progress is absolutely happening. Engineers are developing these incredible innovations like liquid and immersion cooling, which are way more efficient than just blowing air around. AI is being used to predict energy needs in real time to prevent waste. Hyperscalers are now the biggest corporate buyers of renewable energy in the world, and some are even exploring a future with on-site power from small modular nuclear reactors. Pretty wild.
So this brings us to the central tension, right? The thing that's going to define the next decade of our digital lives? How do we balance our relentless demand for more data and more power with the very real physical limits of our planet?
And just when we thought the demand couldn't possibly get any higher, along came the AI revolution. Training and running these powerful AI models requires a whole new level of computing power, which is fueling this unprecedented demand for even bigger, even more powerful data centers. It's creating this vicious cycle of consumption, which puts us in this incredible high-stakes race. On one side, you've got our ever-growing appetite for data, supercharged now by AI. And on the other, you've got our ability to innovate toward greater efficiency. And that leaves us with the single question that is going to define our digital future. Can our innovation outpace our appetite? That is the challenge, right at the very heart of the cloud.